Welcome back. This is going to be a long video, but it's going to be worth it. We're going to talk about long division of polynomials. It's something that you're going to use in a lot of branches of mathematics as you move forward in an algebraic and calculus pathway. So it's very specific on how to do this. It's used in some very specific places, but if you know how to do long division of polynomials starting now, it's going to really benefit you when you get to something like college algebra and then calculus 2 and calculus 3, because it calls for that, and oftentimes students have never seen it, never even heard of it. They've seen something called synthetic division, which works a lot of the time, but it doesn't work unless your coefficient of x is 1. And so I'm going to show you how to deal with this. So we're going to talk about long division of polynomials, where it comes from and how to do it, because we've done everything else. You now divided polynomials by monomials, but we don't know how to divide several terms by more than one term. That's what this video is about. You know what it stems from? It actually stems from regular old division. I'm going to show you how to deal with this. It's more of a how-to video than like a theory video. So how to do long division of polynomials and some problems that people run into. But it's based on regular old long division. How we deal with long division? Well, we start dividing the smallest numbers we can by whatever you're dividing by. So we can't divide 4 by 5, but we can do the next place value, do 49 by 5. Stick with me here. So 49 divided by 5, well, that would be 9. And when we multiply, remember that we multiply, we get 45, and then we subtract, and we get 4. And what you do after that is you bring down the next place value, and you do it all over again. And you divide now 43 by 5. And we're all very used to this, hopefully. And then you multiply and you get 40. And you subtract and you get what's called a remainder. Now, I want to focus on the remainder right now. If you have a remainder of 0, which we don't in this case, but if you did, that would be said to be, well, divisible by 5. And you would get some sort of quotient that is your whole answer. That's when you get a remainder of 0. You say, oh, well then 5 was a factor, whatever number that is. If you have a remainder, 5 is not a factor of that number. It did not divide in evenly. What you do with that remainder is important. You either say it's a remainder, and then to check your work, you would multiply 5 times 98, and then you'd have to add that remainder after that. But instead of just calling it a remainder of 3, you could write it as 98 and 3/5. In general, you can take your remainder and make it a fraction over what you just divided by. That's important because we're going to use that in some of this work right now, specifically that example. So let's divide some polynomials. It's not that hard. There's just some key points that you need to know. The first key point, when you set up your division, your top polynomial goes inside of your division symbol. So when we're dividing, we must always do that. So we start with 2x cubed. Man, the next thing, this is the biggest thing. It's where people screw it up the most. I swear this is it. You need a place value for every potential power of x. So if you start at x to the 9th, you need x to the 8th, 7th, 6th, 5th, 4th, 3rd, 2nd, 1st, and a constant. You need a place value for, now you're not gonna, you'll always have a constant, because if you, well, you'll always have a constant, because if you didn't, you could factor out an x and you wouldn't be dividing by what you would. But anyhow, like 99% of the time. But you need a place value for every potential power of x less than your degree, your largest power. So in this case, we have 2x to the 3rd. We need an x squared. Even though it's not here, you're going to have it. So when we have x to the 3rd power, well, there are no x squareds. Give yourself 0 x squareds. Trust me, this is the most missed concept in long division of polynomials. People write this instead of having that, and they get all jacked up on Mountain Dew because they have no idea what to do next. And I'm going to show you why this would be an error if you forgot that. So I put 0 x squared. Some people just leave it blank. That's fine. I prefer the 0. And then finish it off. And check your work. We start with a power 3. That was in order. We have a power 3. We did a power 3, a power 2, power 1, and a constant. Power 3, power 2, power 1, and a constant. There just happens to be no power 2's. There's 0x squareds. That's what we have. Again, if you had like a power 9, you'd have to have a something to the 9th power, and then even if you had no x to the 8th, you have 0x to the 8th, 0x to the 7th, all the way down into your constant. And whatever you're dividing by goes outside. So the key ideas here, the numerator goes inside, denominator goes outside. You need a power for everything less than your largest power, 3, 2, 1 constant. Now, the second biggest piece of information I can give you, there's 3 important concepts. The first one was a power for every potential less than your degree. The second is your first terms are all that you need to worry about. I promise. Your first terms are all that you need to worry about. So what I mean by that is your quotient is determined by dividing your first terms. Distribution takes care of everything else. Seriously. So what I mean is just divide 2x to the third by x to the first. Divide your first term by your first term. Put that answer here. Now, what's awesome is you already know how to do that. You know how to simplify this stuff. If you don't, go back and watch the last few videos. We've already divided monomials by monomials and polynomials by monomials. This would be 2x squared. You're going to notice a pattern right away. When you're dividing a polynomial by a linear, you always reduce this power by 1. That's it. If it's not linear, you reduce it by whatever that power is. That happens every time. So we're taking our first term, dividing it by our first term, and putting whatever our answer is right here. That pattern works for all division of long division of polynomials. Now, why doesn't the 1 matter in this answer? Well, it doesn't matter because just like how we multiplied 9 times 5 and got 45, we're going to multiply 2x squared times what you divided by. This times what you divided by, this times what you divided by. However, there's more than one term here. So when you multiply, you're going to have to distribute. That's where the 1 comes in. So we distribute 2x squared times x. That's 2x to the third. I'll tell you what, if you're not getting exactly the same thing here for your first 2 terms, you're doing something wrong. You made a mistake on your division. So we distribute 2x to the second times x, 2x to the third. 2x to the second times 1. Check this out. It's why you have that. 2x to the second times 1 is 2x squared. Now, if you hadn't had a place value holder for that x squared, you would get very confused on the next step. Where does this go? Well, if you didn't have that here, you'd have a minus x. And you'd try to line that up and go, those aren't like terms. Yeah, precisely. That's exactly why you have to have a place value holder. That's the biggest miss that I see when I'm looking at students' work. That's the biggest one I see, is people just don't have that. So, long story made real short. This goes inside, this goes outside. Use your first terms only to determine what goes up here. Just your first terms. So 2x cubed divided by x is 2x squared. Your distribution takes care of everything else for you as long as you have your place value holders. So we distribute to get these 2. Just like we did here. 9 times 5, you get this. Now, we bring down the next term, yes, but not before subtracting. So when we subtract 49 minus 45, we get 4. You're going to subtract. This is the third main concept, the last one that I have to get you to get. You're going to subtract. But what you're subtracting, because you distributed, it's now a polynomial. You're distributing not one term, you're distributing both. You're subtracting both terms. You're subtracting 2x cubed minus 2x cubed. Of course you're going to get 0. That's the whole point here. You're going to get 0. But you're now subtracting 0x squared minus 2x squared. Most people, if they're going to make a mistake, you can see, you know what they're going to do. They're going to give me this. That's what's going to happen. Because they look at this and go, oh, yeah. No, you don't. No, you're subtracting. In fact, you're doing this term minus whatever that term is. So we actually have negative 2x squared there. That is a big deal. So the big concepts, this is it, man. If you get this, then you're good to go. For pretty much the rest of it, I need to show you what to do with remainders, but that's it. The key concepts are every potential power in order, 3, 2, 1 constant. This goes on the outside. Use your first terms only to determine what goes in your quotient, and make certain that you are distributing accurately. After that, we're subtracting term minus term minus term. All your signs are going to change. Now, we bring down the next term just like we did here. We brought down a 3, we're going to bring down a minus x. And we start all over again. So let's go through it again. We're going to take our first term divided by our first term. So I'd write off to the side. Negative 2x squared divided by x, that's going to give us negative 2x. That right there, taking your first term divided by your first term. Don't worry about that 1. Who cares? Don't worry about that term. It doesn't matter. It's going to be taken care of through distribution. First term divided by first term. That's negative 2x. That is what we write right here. So negative 2x translates to a minus 2x. And then we continue. If we distribute, we're now distributing negative 2x, this guy. Negative 2x times x and times 1. So we're going to distribute that. Negative 2x times x is negative 2x squared. Check your work right now. Make sure that you get exactly the same thing. That's how we check our work. And then negative 2x times 1 is negative 2x. So we've now distributed our second term times this polynomial that we're dividing by, that binomial. Negative 2x times x and negative 2x squared, negative 2x times 1, negative 2x. And now just like before, if we had more steps, we'd subtract. We're going to subtract right now. Just be careful. That's the biggest thing is sign errors. Negative 2x squared minus negative 2x squared, minus negative, you're adding, that's 0. This is how we check our work every time. But be careful here. Negative x minus 2x, that would have been negative 3x, but we're not doing that. We're taking negative x minus negative 2x. That's negative x plus 2x. Your signs have to change. So you're actually adding 2x. That's going to give you x. Can you see how easy it is to make mistakes? It's so easy to accidentally add when you should subtract or subtract when you should add. It's too easy. Now, lastly, we're going to bring down our last step, our last term. Hey, one more time. We're going to divide first term by first term and let distribution do the rest. So x divided by x, first term divided by first term gives you 1. That is what goes here. So plus 1. When you use that term to distribute, 1 times x is x. That's great. 1 times 1 is 1. Oh my gosh, look at that. When we subtract, we have exactly the same thing being subtracted. You're going to get 0. If you get a remainder of 0, this is huge. I can't even stress this enough. When you get onto like a college algebra level, you're going to be asked to do the rational zeros theorem, and you're going to be asked to find factors. When you do long division and you get a remainder of 0, just like it would have been here, it says that this is a factor of this. It says that it evenly divides it. That's what a factor is. It will help you find factors. It will help you find zeros. It will help you find roots. It will help you graph a polynomial. It's amazing, okay? And it stems from long division of polynomials, which you're learning right now. So remainder of 0 means that thing divides that thing. And this is your answer. And in fact, you know what? If you multiplied that, if you multiplied these two together and distributed like I taught you how to do, you're going to get your original. It's going to work. That's how you check your work. So you would distribute this. So x plus 1 times this must give you that numerator. If it doesn't, you've made a mistake. So we're learning the whole thing together. We're learning that every power must exist. This goes on the outside. We use first terms only, all the way through, to determine what your quotient is. We distribute to figure out what we need to subtract. We subtract term minus term. We bring down the next one, and we do it all over again. If you get a 0 at the end, it means that you divided this by this, and this divided it evenly. That's called a factor. So our quotient doesn't have any remainder in it. I'll show you what to do with remainders in the next example. So let's set this thing up first. Our top, I'm not gonna really pause and have you do any here. I'm gonna walk you through like 5 examples. It's gonna take a while, but I wanna show you everything that can happen. So we set up our division appropriately with this on the inside. Now our highest power is 2. I don't have any missing powers. So power 2, power 1, and a constant. On the outside, we put our the denominator. Now, no matter what you do, man, you're just looking at your first two terms. So I would look at 4x squared divided by 2x. That gives me 2 and x. Yeah, we need to know how to divide. So 2x is what we're going to put right here. When we distribute to every term of the polynomial that we're dividing by. So 2x times 2x is 4x squared. Hey, that's identical. That's exactly the way checker work. 2x times negative 1 is minus 2x. And we are going to subtract this polynomial minus this polynomial, term for term, just like you practiced already. We've already done that several videos ago, subtracting polynomials. We knew that when we subtract polynomials, we change every sign. We subtract one term and the next term. We are always subtracting every term. It says you're subtracting a polynomial. Let me subtract every term. 4x squared minus 4x squared, that's 0. 6x minus negative 2x, that's 8x. That's not 4x. Subtracting negative is actually adding. If you bring down negative 1 or minus 1, we just do the whole thing over again. Divide our first term by our first term. That gives us 4, just 4. If you distribute the 4, don't worry about the 2x, you've already done that. Distribute the 4, 4 times 2 is 8x. 4 times negative 1 is negative 4. Now it looks funky, what am I supposed to do with that? Don't worry about it. This just is telling you that this is not a factor of this. This will not divide this evenly. It won't divide it. What's going to happen is that we are going to get a remainder. 8x minus 8x, yeah, that's 0. But negative 1 minus negative 4, that's negative 1 plus 4. It's going to give you 3. That 3 is your remainder. It says that that 2x minus 1 didn't divide it evenly. It's not a factor. So when you move forward, you go, hey, is this a factor of this? No, you got a remainder. You got a non-zero remainder. Now, what you do with that remainder, sometimes it's enough to just say we have a remainder of 3. But what you can do with it is one of two things. You either say that you have a remainder of 3, or much like this. We had 98. We have 2x plus 4. We had a remainder of 3. We have a remainder of 3. We can put that as 3 over what you divided by, your denominator. We can put this as 3 over what we divided by, your denominator. And add that to your quotient. If that had been negative, you would have subtracted that. So your remainder becomes a fraction, your remainder becomes a fraction added to your quotient. In fact, this really is added to. That could be 98 plus 3/5. That's 98 and 3/5. This is 2x plus 4 plus 3 over 2x minus 1. And you know what? To check your work, you can actually do this. You would multiply these two and then add your remainder. That's equivalent to finding the common denominator and adding that together. It's going to give you exactly what that is, which is pretty rad. So take your quotient. If you have a remainder, if you don't have a remainder, it doesn't matter. You're done. I've already shown you that. But if you do have a remainder, you put your remainder over what you just divided by and add that to the back end of your quotient. That's it. That's long division of polynomials. I'm going to show you some more advanced ones right now, but that's pretty much the idea. So we'll do about 3 more. I'm going to erase the board real quick and show you this to you. I'd like to show you advanced ones where you don't divide by linears, because that happens, and for students who have only learned synthetic division, they get real stuck. And they go, what am I supposed to do now? Well, you never learned it. So I want to teach that to you now so you don't have to learn it later when it's required of you. If you'd like, while I'm erasing the rest of the board, why don't you take a moment and set that up. Make sure that you know what goes inside and what goes outside your division. So inside, we're going to put the first expression, that's what would be on the numerator, so that's what's going to go inside our division. I'm going to make sure that I have every potential power less than our degree, the largest power that's up there. So power 3, and I've got a power 2, power 1, and a constant. It's looking really good. It's looking set up perfectly for me. I'm making sure that what I divide by, much like a fraction, goes outside, goes here in front. Now, this can blow a lot of people's, just blow their minds. But how can you do that? The same exact way. Exactly the same as last time. Exactly the same. All we're doing is you're dividing your first term by your first term. I'm not lying to you about that. I would never lie to you about math. Other stuff, maybe, but not about math. In order to figure out your quotient, take your first term, divide it by your first term. That's it. So off to the side, you might even write this, 2x to the third divided by x squared. Hey, that's going to give you 2x. That's what goes here. Since we have every potential power 3, 2, 1 constant, when we distribute, we're going to have 2x times x squared, that's 2x to the third, that's great. 2x times negative 2, that's negative 4x. Negative 4x. Put it in the right spot. So 2x times x squared, that's 2x cubed, great. There aren't going to be any x squareds. There's no x's, so you can't get an x squared. This is going to give you negative 4x. Put it where it's supposed to go. So here, x cubed, awesome. There's nothing for the x squared. That's okay. You can put plus 0x squared if you'd like. You didn't get any. There was nothing to distribute to give you x squareds. That's okay. It's a place value holder. And then minus 4x. And then remember, we are going to be subtracting that entire polynomial that you just created from the one you were given. When we subtract that, 2x cubed minus 2x cubed, nothing. Negative 4x squared minus 0x squared. You still have negative 4x squared. The reason why I have that there is so that you don't forget about that one. Because a lot of people go, oh, I do this, I do that. What happened to x squared? I don't know. There's nothing. Well, you're subtracting nothing from it, but it's still there. Negative 4x squared minus nothing is still negative 4x squared. Negative 3x minus negative 4x. Oh my gosh, I'm adding now. That's plus x. And let's bring down our last term. Okay, now to figure out the next term. Honestly, it's just first term divided by first term. So we did that once, we distributed, we subtracted. We're going to do that again. That's negative 4. That's what goes here. So minus 4. First term divided by first term gives you what goes in your quotient. When you distribute, make sure you're distributing with the sign. You know, sign errors, they always get us. Negative 4 times x squared, negative 4x squared. I'm not going to get an x. That's going to be missing. So I'm not going to get anything. That's 0 x's. I can't get it. When I distribute this, it's going to go here and here only. So negative 4x squared, great. And then plus 8, fill in the middle with a 0. If you're missing a term that's here, fill it in with a 0. Or leave it blank, that's fine, but don't forget about that guy. Now when we subtract, hey, you're subtracting term by term. That's awesome. This is going to give you 0. This is going to give you, let's see, x minus 0x. That's still x. And then 3 minus 8 is negative 5. Once you get down to a constant here, whatever's left is your remainder. There's no way that you can divide x by x squared and get something up there that's relevant. If you did, you'd be kind of stuck with your constant and you start going down a rabbit hole that's kind of nasty. You don't need decimals. You brought down your last term. You don't need to do anything else. When you get a constant in your quotient, you are done. Whatever you're left with, if there's anything there. Now, let's go back a little bit. That's not 0, which means this is not a factor of this. This is not a factor of this. It did not divide it evenly. You have a remainder, and that's it. After you write the constant in your quotient, whatever you're left with is your remainder. How we write it? Well, that's your remainder. You can write this as your remainder over what you're dividing by You're done. That's it. When you get to calculus 2 and you do partial fractions by decomposition, you're going to have to do some of this. You're going to have to start dividing polynomials in order to figure out how to decompose those things even better. That sounds pretty advanced. I suppose it is, but it all starts right here with you being able to get this far. So again, long division of polynomials sets up your first or your numerator inside, your second or your denominator outside. Has a power for every potential less than your degree. Takes first term divided by first term only. Distribution does the rest, we subtract term by term. First term only. Distribution does the rest, we subtract term by term. When you've written down your constant, whatever you have left is your remainder. Write that remainder over what you just divided by, and that is your final answer. That's pretty cool. Let's do one more. Well, two more. Two one-mores. If you'd like to jump ahead and do that while I'm going through it, I'm going to go through pretty quickly here. I want to make sure their setup's good, just 2 times through to make sure we got it. But try it on your own if you'd like. So here's our setup. Our numerator always goes inside, and we have to have a power for every potential term less than that degree. So I need a 3, a 2, a 1, and a constant. I have a 3. I don't have any x squareds, but I'm going to give it 0. I don't have any x's, but I'm going to give it 0, and I have a constant. I need a degree. I need a power for every potential less than a degree. On the denominator, I just write that out. I let my first term divided by my first term dictate what my quotient is. So you don't have to write it out separately if you don't want to. X to the third divided by x squared is going to give you x. Then we distribute to everything. X times x squared is x to the third. X times x is x squared. X times 1 is x. And when we subtract, well, x cubed minus x cubed is 0. That's awesome. 0x squared minus a negative. You're adding. That's 1x squared plus x. Oh, I'm sorry. Almost made a mistake, didn't I? 0x minus x is negative x. And bring down that last term. You're going to love it when you see this, and they're identical. Because what it's going to tell you is that the factor. Usually I'm telling you though, your first term divided by your first term. What's x squared divided by x squared? What's 1? Positive 1, right? Plus 1. When you distribute that 1, don't worry about the x. You already did that. 1 times x squared, 1 times negative x, 1 times 1. You get exactly the same thing. When you subtract it, you get 0. Think about what that's telling you. You got a remainder of 0. That says that this divided this evenly. It said that this is a factor of this. This is a factor of this, and your quotient has no remainder. We just really simplified that problem. That's pretty cool. Okay, the last one. Setups everything. Make sure you have a place value for every potential power less than the degree. So I need a 4, a 3, a 2, a 1, and then a constant. I have a power 4 right there. Now I need some space. A 4. I didn't have any 3s. Like go fish. I didn't have any 2s. I got no 1s, but I do have a constant. So I have a power for every potential, I have a place value holder for every potential power less than degree, and then my second expression, the thing I'm dividing by, or my denominator, goes out front. This, to be honest with you, would be something that synthetic division would do beautifully. There's something called synthetic division. I'll do a lesson on it much later when we get very good at this. I do not want people learning synthetic division before they learn how to do long division, because this sort of thing you can't do it with synthetic division, the way that we normally teach it. This is something that you could. So if you want to look that up right now, that's awesome, but don't misconstrue how to do a problem like that, how to do a problem like that. Synthetic division works when you have x to the first power. That's when it works well. Now, we can still do it long division, which is nice, because we know, hopefully we're getting how to do this. First term divided by first term is what makes your quotient happen. So x to the fourth divided by x gives you x cubed. Distribution follows up with the other terms up here. So at first it looks like, what am I supposed to do with that? Nothing. Distribution is going to handle it for you. That's also why we have every potential power, because you're going to have some things by your distribution come up, some terms that come up that if you didn't have these, you'd have no idea where to put them. So x to the third times x is x to the fourth. I'm checking my work, looks great. X to the third times negative 2 is negative 2x to the third. For the last time, imagine if you hadn't put that. That would now be under 16 and you'd be very confused. What do I do now? I don't know, we screwed it up. When we subtract, make certain that when we're subtracting, you're subtracting term minus whatever that is. All your signs will change, all of them. You're always subtracting, therefore all of our signs change in that second polynomial. 0 and positive 2x cubed. Bring down our next term and start all over. 2x cubed divided by x is 2x squared. When we distribute, we have 2x to the third minus 4x squared. Well, we're subtracting now. Subtract term by term. So this is going to give you 0, 0 minus a negative, that's 4x squared. Bring down your next one. And it's just an algorithm, this process that lets us divide. Divide your first term by your first term. 4x squared divided by x is 4x. Notice how your degree depletes by 1 every time you divide by a linear, and your degree depletes by 2 every time you divide by a quadratic. So, well, it at least depletes. So we're dividing by 2, we're dividing by 1, so we're really subtracting exponents every single time. So 3, 2, 1, next one should be our constant. So 4x times x is 4x squared. 4x times negative 2 is negative 8x. When we subtract, hey, that's 0, but 0 minus a negative, you're adding, that's 8x. And last step, divide 8x by x. It's always first term divided by first term. It's going to give you 8. We're going to distribute 8 times x is 8x. 8 times negative 2 is negative 16. Oh, I love it. That gives you a remainder of 0. What's it tell you? You need to know what it tells you. Remainder of 0 says that this divided this evenly. This divided this evenly. Same thing. It's saying this polynomial is a factor of that polynomial. That's what it's saying when you get a 0 remainder. Talks about zeros and roots, x-intercepts, factors, all those things come together when you get to college algebra. Right now, we know that this divided by this equals that quotient. In fact, if you wanted to distribute, if you really wanted to, take this times this, simplify, combine your like terms, I guarantee you'll get that. That's the idea. That's how long division of polynomials works. We now know all of the operations with polynomials. You know how to add them, subtract them, multiply them, and now divide them, both by monomials and long division of polynomials. We are done with talking about how to do those operations. The next video is focusing on going backwards. So instead of multiplying and dividing by long division, maybe we do the opposite of distribution. We're going to learn about factoring. And if you know how to factor, the next several videos are going to be, well, after factoring, next videos all work on factoring. Should be awesome. So we'll spend some time learning how to factor. I hope this made sense, and I'll see you for the next few videos.